the trend of the data, or what's happening with the data. That's where statisticians use it a lot. They're looking at a trend line, what's kind of happening to the data. So to make a scatter plot, it's pretty simple. To make a scatter plot, you use the data as coordinate points. Assign each data set one of the axes. So you can put temperature on one, ice cream sales on the other, things like that. It's just like when you were little and you made bar graphs, except we're getting a little more technical with it. Any questions so far? Anything I've confused you with? Okay. So to make a scatter plot, you just take the two things you're comparing and put one on the X and one on the Y. So if you notice, they put words on the X, minutes on the Y. What do you suspect's going to happen? If you're typing, what do you suspect's going to happen compared with minutes and words? What do you think the trend's going to be there? Gonzalo? Well, what relationship are words and minutes going to have together? If I'm typing, boom. Okay, Charlie. Words per minute. The more minutes I type, what should happen? The more words I type, right? That's what we're hoping should happen. Now, there could be some outliers. Somebody could type slower, but technically, the more minutes I type, the more words I should type. So all you are doing is really making points on the scatter plot. So you go over to 14 because it's words. So 14 words in 5 minutes, and you put a dot. You're just putting all of the dots on your scatter plot. So you go over to 10 up to 3. So in 10, I can type 10 words in 3 minutes. You should have a bunch of points on there. Keep going. Now everyone's is going to look a little bit different just because it's not precise, but they should look similar. It should look something similar to mine up there. Now, they're not all going to look the same because we're all kind of judging it on our own, but it should look similar. You should have 7 points plotted. And make them visible. If you're just putting little dots, those aren't visible. All right. And we say that that's a positive correlation. Why do we think we say that's positive? What makes you automatically think, oh, it's positive? Lucy? Yeah, because if you read it from left to right, the points are going upward, right? So to have a positive correlation, both things either need to be going up or both sets of data need to be going down. So an example of two things going down would be as temperature decreases, ice cream sales decrease, right? Because you typically eat ice cream when it's cold. So when temperature, or warm. So when temperature decreases, ice cream sales decrease. That's a positive correlation because they're both going down. But you could spin it too and say, as temperature increases, ice cream sale increases, right? So those are positive correlations. They're both going up or they're both going down. Does everybody understand that? All right, at your table, come up with your own positive correlation. All right, to be a negative correlation, they have to be going opposite each other. So as one increases, the other should decrease. So an example of that would be as temperature increases, winter coats decrease, right? Winter coat sales decrease. It would be like saying, as contamination of meat goes up, the sale of burgers is going to go down because people probably aren't going to eat burgers if there's been this recall or contamination. So things like that, things that negatively affect each other. Everybody understand that one? Okay, and no correlation is something like this where the dots don't form anything. There's no relationship. This one's pretty easy because you can just pick two random things that don't affect each other. Like temperature does not affect Temperature does not affect how well you sleep. That doesn't do it. Okay, stop. Can I talk? So technically, no matter what it's doing outside, you probably sleep just as well because your house is regulated. So in our world, doesn't really affect us. It could affect us in other worlds, but in our world, it probably doesn't. So two things that aren't on the spectrum, like ice cream sales compared to t-shirt sales. Those aren't correlated at all. Doesn't matter how much ice cream people are eating, t-shirt sales aren't going to change because of it. Okay. Trend line. Okay, trend line. If there is a correlation, so if you're saying it has positive correlation or negative correlation, you can draw what we call a trend line. So if there is a correlation, you will draw a trend line. Another word they use for this is line of best fit. They also call it line of best fit. Line of best fit and trend line are the same thing. All right, so when drawing a trend line, you want it as close to each data point as possible. Now it's a line. So you can't just sit there and connect all the dots because that's not a line. So that's not a trend line. A trend line just needs to be as close to many data points as possible. Second, it needs about the same number of points on each side of it. Doesn't have to be exactly, but you don't want 10 below it and only 1 above it. That's not a good trend line. Third thing, it needs to go through, directly through, at least 2 points. At least. If it goes through more than that, that's great, but you definitely want it to go through at least 2. Everybody with me? Now, the nice thing about trend line is everybody's trend lines are going to be different. Because where Margaret thinks a trend line is may be different than where Lila does or Spencer. Right now, we're all going to draw the same trend line for the purpose of the notes. But no, on the homework and things like that, your trend line should be similar but not exact. Okay? So if I was Mary Esther and I was going to draw a trend line, you wanted to hit at least 2 points. Everybody with me? But you also don't want to put it up here. That's not going through all the data. You kind of want it in the middle, but you don't want to put it all the way down here and be like, oh, it went through these 2. That's not a good indication of what the data is doing. Make sense? So you want it to go through the middle of the data, but you don't want it to be crazy. So this is comparing the temperature to beach visitors, right? So as the temperature increases, hopefully the visitors increase, right? So I'm going to draw it through about right. I'm going to draw it through these 2. So I'm going to draw it through these 2, something similar to this. So you will draw it something similar to that, but have it go through those 2 points at least, please.
Which 2 points?
The 2 points that are on my the first 2. Once your trend line is made, you'll be able to write a linear equation. Now, remember the 2 things. Put the ruler down. That's obnoxious. Remember the 2 things you have to write a linear equation. You have to have slope and a y-intercept. You have to have those 2 things. So you're going to do the same thing. You're going to pick 2 points. And the nice thing is I purposely went through these 2. So I went through 84. So when it's 84 degrees outside, they're saying there's 225 guests. When it's 86 outside, they're saying there's 300 guests. I just picked those 2 points because they go directly through it. You really could pick anything. I could have said, it goes through at 88 at about 350. You can pick any of them as long as it falls on your trend line. Okay, so right now find the slope. With your table partner, find the slope. Find the slope. So now what we have, this is telling us the slope. So what this is saying is, every time temperature increases 2 degrees, we get an additional 75 people. So every 2 degrees, you get an additional 75 people, right? So now this is where mathematically it gets a little unrealistic. We're going to find the y-intercept, but that's going to be saying when the temperature is 0. How many people are going to be at the beach when it's 0 degrees? Zero. Now, mathematically, it's going to give us kind of a high negative number, but that makes sense mathematically. It's saying you're going to be in the negative. No one's coming to the beach. So you still need, even though realistically it doesn't make sense, mathematically it makes sense. So we're going to figure that out. So all I'm going to do is we know y equals 75 over 2x plus b. Now we know how to do this. You have to plug in a point. So I'm going to plug in the second one. So x, y. I'm going to plug in 300 equals 75 over 2 times 86 over 1 plus b. This is going to give you a super high negative number. But mathematically, it will make sense. And realistically, it makes sense. If it's 0 degrees, you're probably in the negative. You can't have negative people, but you're going to be in the negative. Yes, sir. I just made it so I can multiply straight across. Because it's just 86. Because that's not the y. Okay, so now I've done the math work for you. I did 75 over 2 times 86 over 1 and got 3,225 plus b equals 300. And then I subtract. So realistically, you can't have negative people, but it makes sense. You're not going to have anybody. You would have negative 2,925 people for your y-intercept. So if your weather was 0, you're going to have a lot of negative people. All right. So now you're going to write the whole linear equation. Y equals 75 over 2x minus 2,925. If you don't like it like that, you are more than welcome to write y equals 75 over 2x plus negative 2,925. Both are correct. So, the only new thing you learned is drawing a trend line. This is from last chapter. So the only new thing you learned is how to draw a trend line, then write the equation from that. But you should be able to do that.